absolute value function up 8, you would write it as the absolute value of x plus 8. So it gets a big plus 8 on the outside of the function. And if you want to take the absolute value function and move it down 8, I'm just picking the number 8, it's a big minus 8 on the outside of the function. So that would be the first thing. If you wanted to put on a note card like this function with up and this function with down, because it starts to get confusing when there's 8 transformation rules, but you need to be really good at these transformation rules because we're going to use them again in exponential, rational, log functions all the way through. Okay, up and down, that kind of makes sense, add 8 or subtract 8. It's the right and the lefts that get people, because to move to the right, don't you want to like add, moving to the right? Moving to the left, I kind of want to subtract, and it's actually the opposite. So to move the absolute value graph to the right, I'm just going to stay with the number 8 here. It'd be x minus 8 on the inside of the function. And the reason for that is, what happens when you plug in the number positive 8? 8 minus 8 gives you 0. So what is the x-intercept? 8, 0. So if you think of the parent function for absolute value, which is here, if it now has an x-intercept at 8, 0, see how it's been shifted to the right by 8, even though we wrote x minus 8? It actually shifted the x-intercept to the right. So it's opposite. I just tell people inside the parentheses or inside the function, everything's backwards. So if you want to go to the left, it's x plus 8. Do you remember this being tricky with the lefts and the rights? I just think about where is the x-intercept, and that helps me check my answer. So up, down, left and right are inside, so the x's are moving to the left and the right. That's why it's inside the function, because it's just moving x. When it's outside the function, it's moving that entire function up 8 units, or the entire function down 8 units. So these 4, keeping those 4 straight is tough. You got to study it and practice it a bunch. Let's write those same 4 rules with a quadratic now, x squared. So it would just be x squared plus 8, or x squared minus 8. So that's outside the function, up 8 or down 8. And then same thing, if I want to move left or right, it's going to be inside the parentheses with x. So x minus 8 squared, x plus 8 squared. So in Algebra 2, we did a whole exploration, graphing a bunch of functions, coming up with these rules. So now I'm giving you the rules, and you've got to kind of memorize them if you've forgotten up, downs, lefts, and rights. But we'll practice them a bunch. All right, so I'm going to move down. So then there's another transformation rule about flipping your function either upside down over the x-axis or reflecting it over the y-axis. So there's something kind of funky with these two functions. If you have symmetry, right, you will see this if it flips upside down, won't you? But what happens if you flip it this way? This arm is just going to land on top of this arm. So you won't physically see a change if there's already symmetry. You'll only see a change in something like maybe the square root function, right? That flipped upside down would look like this, and flipped this way, it would look different, right? So sometimes with symmetry, you won't see a transformation, but the equation could still look different. All right, so if this is the absolute value function and you flip it upside down, it would look like this. You're flipping it outside of the function. And then if you just want to flip it over the y-axis, the x values are negative. So all of these x values land on top of this side, and all of these x value leg kind of moves over here. So the x's are switching places, so you might not see it if there's symmetry. And then for x squared, it's negative x squared, or in parentheses, negative x squared. So you'll only see a change if there's not already symmetry. So these can be tricky. I think about reflecting upside down, it's reflecting the entire function upside down. So it goes in front. And then over the y-axis, just my x's are getting flip-flopped, so the x is what's being changed to negative, not the whole function. So however you can keep those straight in your head. And then vertical stretch, I'm only going to talk about vertical. Your book might also talk about horizontal. One transformation is enough. So if you vertically stretch it, it gets taller and narrower. So it's going to make the function look like this. Vertical stretch is towards the sky, like a tree that's reaching towards the sun. It's stretching vertically taller. So your parabola has twice the steepness, like this, twice as steep. And then a vertical shrink is a fraction less than 1. So like 1/3, for example, or 1/2, it's going to look like this. So it's going to be shorter. Some people think of this as horizontal stretch. I just call this vertical shrink. It's less tall or it's more tall. So this one would look like this. So 1/3 x squared. So those are your 8 transformation rules, which is a lot to keep track of. I'm not going to give you 4 transformation rules at once. It'll probably be like 1 or 2 of them in a problem. So if you take a look at the graphs on the next page, this is using, let's see, the cubic function. So all the different parent functions are represented here. So this is a good opportunity for us to practice the parent function with one transformation. So I'll do this page kind of with you to practice. And then I'm going to have you try the page 104 as kind of some guided practice on your own. All right, so number 1, the cubic function. Before I even do the +2, let's remember the key points of that cubic function, right? 0 cubed was 0, 1 cubed was 1, and 2 cubed was 8. And then it went the same on the other side. Oops, oh no. So -1 cubed was -1. And -2 cubed was -8. So it's okay to dot in the parent function. That's how you're going to do these transformations. All right, what does the 2 do? What does +2 do to the function? It shifts everything up 2 units. So now, either in a different color or with an X or whatever, shift everything up 2, and that's going to be the point that you connect for your transformed function. So up 2, right? So my transformed function is the stars. If you have them both on your graph on the quiz, I'll know that I'm looking at the correct one, the transformed one, because I know which one the parent is. So that's it. I would not shortcut plotting the parent. I would just plot the parent every time, because even I plot the parent function. I don't just do the transformation. All right, so that is a cubic function reviewed there. So the next one is a quadratic. So what's going to happen to the quadratic? What does this x minus 4 do? Up, down, left, right, flip. So which one is -4 on the inside? What does that do? It goes to the right by 4. So I'm going to graph the parent quadratic and then shift everything right 4. So where's the vertex of the quadratic? This is going to be parabola. So the vertex goes where? For the parent function. 0, 0. And then remember our key points are, if I square 1, I get 1. So over 1, up 1 on both sides. And then from the vertex, if I go over 2, 2, 3, I'm up 4. And then over 3, I'm all the way up here at 9. So this should be that smooth curve, right? So there's my parent. I'm going to shift all of those points to the right by 4. So, or if you wanted to just plot, it's almost like plotting the parent function again. So start at 1, 2, 3, 4, over 1, up 1, over 2, up 4, 1, 2, 3, 4, and then over 3, up 9. So you can either kind of plot the parent function again or actually move all of those points to the right by 4. So these are like what kind of your quiz questions will be like on Friday too. I'll give you one of the parent functions that I'm assigning, which is like the 7 or 6 different functions from yesterday. with like a one-step transformation without a calculator. So you'll have to know the parent functions and know the transformations. Can I go down to the next one? So here are two transformed absolute value graphs, just because those might be hard for you to remember. What does this negative do when it's outside of the absolute value? Does it flip upside down or does it flip over the y-axis so you don't actually see it? Over the x-axis, so upside down. So if you want to graph the parent function, remember it was a slope of 1 and a slope of -1 from the origin, that V-shaped parent graph. So all you're doing is taking that and you're flipping it upside down from the origin. And if you drew that all in pencil, I know which one is the right answer. So don't feel like you got to erase the parent function. To me, that's just showing your work that you did the parent first and then the transformation. Or if you want to do these dots and just not connect the dots and then connect the dots on your final answer, that's fine. All right, what does the 2 do? So the 2 is different. So it's not a up, down, left, or right. It's a stretch or a shrink. So the 2 is going to change basically the slope of this line twice as steep. So each of those y values is going to be double the steepness. So from the origin, doubling 0 is still 0. But the original height over here was a height of 1. So if I double the height of 1, I still go over 1 on the x-axis, but I go up 2 on the y-axis. And then on my original function, when I went over 2, I went up 2. So now I'm going to go over 2 and up 4. So the slope is now 2. So it should be twice as steep because the slope is 2. So whatever the y value was on the parent, you double the y value. You don't change the x value spacing at all. Still go over 1, over 2. So that's double the steepness. Number 5, you should be able to graph. That's just a line, y equals mx plus b. So I don't think of transformation rules with a line. I just think of like y equals mx plus b. So I'm drawing a line that has a y-intercept at +3 and a slope of -1, right? Because if there's a negative sign, it's -1 over 1. So that one, I skip transformation rules with linear. I just know that I'm going to start at +3 on the y-axis and go down 1 over 1. So there's my line through a y-intercept of 3 with a slope of -1. So linear functions are important. I don't want you to not know how to do a linear function, but you can do all these other more complicated functions. All right, and then the last one that I want to do with you, because square root was kind of new yesterday. So let's do the parent square root function. So think of your perfect squares. So our first perfect square was at 0, because the square root of 0 was at 0. I actually don't know if that counts as a perfect square, but our next perfect square is 1, because the square root of 1 is 1. So 1 comma 1. What's our next perfect square that I could plug in for x? So 2 is not a perfect square. I have a list of perfect squares up there too, if you can read it. 4 is the next perfect square. The square root of 4 is 2. So 1, 2, 3, 4. 1, 2, 3, 4, and up 2. And what's our last perfect square that's going to fit? 9. So the square root of 9 is 3. So this is my original parent function. So these x values are going to stay exactly the same, 1, 4, and 9. But I'm going to double each of the y values to make it twice as steep. So 0, 0 is going to stay the same, but instead of going over 1 and up 1, I need to go up twice as much to 2. And then if you double 2, you should be at 4. And if you double 3, you'll be at 6. So see how the red line or the red curve, the x values have stayed the same, but the y values have been doubled the steepness of. And if it was a half, you would just be under this line and you would go a half and then 1 and then 1.5. So it would be less steep by a half. All right. So I'd like you to try on 104, some guided practice here. Writing the equation of the graph. So these are all square root functions. So could you write the equation using transformation rules? And then could you graph the square root function using transformation rules? Some of them have two transformations. So you have to think, all right, does this go right or left? And does this go up or down? So take about 10 minutes and try those like 7 questions, because each of these could be like a quiz question on Friday. And then we'll kind of grade ourselves at 9 and see how we did. If you don't get them all done, don't stress about it. Do 5 of them. But try to do them either, if you need the transformation rules, fine. But try to do them maybe testing yourself, because we just reviewed them. So test yourself first and then double check that you have it right. And if you want to use a pencil, there's some pencils so you could erase it if it's wrong. And here are the answers to the guided practice.